Hey, welcome. Today, we're setting off on a pretty epic quest. We're gonna go behind the screen to figure out the secrets of how video games are actually made, how they go from just a simple idea into this full-throttle engine of fun. So, where does a journey like this even begin?
You've gotta have, right? It's a question every gamer thinks about. Is it some kind of magic? Just a blur of frantic typing? Well, it's actually a super structured step-by-step journey called software development. And on our quest today, we're gonna follow that exact path, right from the very start to the finish line.
And to make this all feel real, we're not just going to talk about theory. Nope, we are going to build our very own imaginary racing game from the ground up. So go ahead and grab your virtual wrench, because we're about to create Turbo Drift. Now, before a single line of code is written, before even one pixel is drawn on the screen, every great game starts with a great plan. This is the planning phase, and this is where we map out exactly what we're building. Honestly, you can think of it as the most important lap of the entire race. So, first things first, we have to think about the player. What do they want? This is where something called user requirements comes in. Just think of it as the ultimate wish list from the people who will actually be playing our game. It's all about the experience, the vibe, the feel. So for our game, Turbo Drift, what would be on that wish list? Well, you know players are going to want blazing fast cars. They'll want steering that feels super responsive and realistic, and of course, a high-score leaderboard so they can brag about their best lap times to their friends. Okay, now that we've got the player's wish list, we need to translate it into a language that developers can actually use. And that's where the functional specification comes in. This is the technical blueprint. It's how we turn a player's wishes into concrete, step-by-step tasks for the game's code. And this table, it just lays it all out perfectly. The user requirement is the what. The car should speed up. It's simple, right? It focuses on the feeling. But the functional specification, that's the how. It's totally precise and technical. If the up arrow is pressed, increase the speed variable by 0.5 until it hits 20. See the difference? That's how we turn a player's desire into a specific instruction the computer can understand. All right, with our blueprint in hand, it's time to move to the design phase. This is the really fun part, where we figure out not just how our dream car will look, but how it's going to think and behave out there on the track. In design, there are two super critical concepts, UI and UX. The user interface, or UI, is all the stuff you actually see, the speedometer, the little map in the corner, the start button. But the user experience, the UX, that's how it all feels. Is it fun? Is the steering too twitchy? A great game has to have both a beautiful UI and an absolutely thrilling UX. So let's talk about the game's brain. The logic of the whole thing is built with algorithms. Now, I know that word sounds kind of complex, but it's really not. An algorithm is just a simple recipe, a set of step-by-step instructions that tells the computer exactly what to do. And here's a perfect example of a simple algorithm for Turbo Drift. It's a crystal clear instruction. Check if a button is pressed, and if it is, do this one specific thing. Every single action in the game, from accelerating to, crashing into a wall, is all run by these little recipes. So how does the game actually run all these instructions at once? It uses something called a game loop. You should think of this as the game's actual heartbeat. It's this constant, incredibly fast cycle that keeps the game alive, running maybe 60 times every single second. It's wild. And this loop basically has two main jobs. First is the update function. That's the brain. It's always calculating physics, checking for collisions, seeing what buttons you're pressing. Then comes the draw function. That's the artist. It takes all that new information from the brain and redraws the entire screen, putting your car in its new position. Update, draw. Update, draw. 60 times a second. Okay, planning's done, design is complete. Now it's time for the implementation phase. This is where we get our hands dirty and finally start building the engine and bringing Turbo Drift to life with real code. But hold on, we don't build the whole beautiful game all at once. We start with a prototype. This is like a rough draft where our amazing car might just be, well, a red square. And that's totally fine. The point isn't pretty graphics yet. It's to test one crucial thing early on. Is the core mechanic of racing actually fun? Figuring that out now saves so much time later. Now, when it comes to the actual coding, there are different tools for the job. You could start with block-based coding, which is kind of like building with digital Legos. Or, if you're ready, you can jump into text-based languages, like Python, writing the instructions out line by line. The cool thing is, both can get you to the finish line.
The engine is built, but our quest is not over, not by a long shot. Now we have to face the gauntlet, the testing phase. This is where we hunt down and squash every single little bug to make sure our game is as perfect as it can be. And there are different kinds of tests. You've got unit testing, where we check tiny individual parts, like just making sure the brake button actually brakes. Then there's iterative testing, which just means we test constantly as we build new things. And finally, my favorite, user acceptance testing. That's when we give the game to real players to see if they enjoy it and can actually figure it out. We've built, we've tested, and now it's time for the final challenge, the evaluation phase. Let's take our victory lap and see if we actually did what we set out to do in the first place. So, did we win? To find out, we have to look back at the goals we set way back in the planning phase. Does the game run without crashing? Check. Can a race be finished in under 3 minutes? Check. Does the leaderboard work? Check. Hey, by these metrics, Turbo Drift is a success. But here's the big secret of software development. The finish line is also a starting line. A developer's work is never really done. The quest just keeps going, even after the game is out in the world. And that's because software development is a cycle. After evaluating, developers often go right back to the planning phase. Maybe they're designing new features, adding new tracks, or fixing bugs that players have found. It's a continuous loop of creation and improvement. So there you have it. From a simple idea through planning, designing, building, and testing, we've completed the quest. You now have the blueprint for creating not just a game, but pretty much any piece of software. So the only question left is, what world will you build?